All right, let's talk about one of the most important, but maybe least understood topics in tech, system design. We're going to peek behind the curtain and see the secret blueprint that lets a small app grow to serve millions or even billions of people.
So, picture this. You build an app. It's your baby. And then, bam, it goes viral overnight. It's the dream scenario, right? But suddenly, it's lagging, it's crashing, and your new users are getting frustrated. That exact nightmare is the problem system design is meant to solve. It's all about planning for success before it buries you.
Look, when you're building for a massive audience, you're up against some really tough realities. Your servers will fail. Networks will go down. Those aren't possibilities, they're guarantees. And on top of that, you're wrestling with wild traffic spikes and the very real limits of physics. You only have so much processing power and bandwidth. System design isn't about hoping these problems won't happen. It's about building a smart, resilient system that expects them to.
Okay, so where do we even begin with all this complexity? Well, like any good blueprint, you start with the absolute simplest foundation you can imagine.
And really, at its core, this is pretty much every application you've ever used. You've got the client, that's you, on your phone. You tap a button, which sends a request to a service. That's the brains of the operation. That service then talks to a database to either fetch or save some info, and then sends a response right back to your screen. That's it. Simple, clean, and the starting block for everything that comes next.
So if we're going to put a pin in it, what exactly is system design? The key thing to realize is that it's not about writing code. It's the strategic thinking you do before you write a single line of code. It's the high-level process of choosing your building blocks and, this is the important part, deciding on the trade-offs you're willing to make, so your system can actually handle a flood of users without falling apart.
All right, we've got our basic blueprint. Now, let's get real. It's time to start adding some muscle to this thing, solving the problems that show up when you move from a handful of users to thousands.
And here it is, our first big, ugly problem. That one little service is doing all the heavy lifting. As more and more people show up, it just can't keep up. It gets slow, and eventually it just gives up and crashes. It's what we call a single point of failure. So what's the play here?
Well, the answer isn't to get one giant, super powerful machine. No, the smart move is to get more machines. This is called scaling horizontally. And to manage all of them, you bring in a traffic cop. This piece of the puzzle is called a load balancer. It sits out front and smartly directs all the incoming traffic, sending each request to a server that's free and ready to work.
So, the big idea here is that the load balancer stops any one server from getting totally swamped. It spreads the load evenly. But it also gives you reliability. Think about it. If one of your servers just dies, the load balancer sees that and just stops sending people there. The rest of the system stays online, and most users never even notice a problem. Okay, problem solved, right? Well, not exactly. All we've done is push the bottleneck further down the line. Our servers are handling the traffic just fine, but now they're all screaming at the database at the same time. The database is now the slowest part of the whole system, and everything feels sluggish again. So what do we do now? The solution here is to put something in between our services and our database. We add a layer of super fast memory called a cache. The whole point of the cache is to hold on to copies of the data that gets requested all the time, things like your profile picture or the details of a popular product. And this is just a game changer. When a request comes in for that popular data, the service doesn't have to make that long, slow trip to the database. Instead, it just grabs the info from the lightning-fast cache right next to it. For the user, the app feels incredibly responsive. And for our system, the database gets a much-needed break. It is a total win-win.
Okay, so our app is snappy now, but it's also kind of brittle. Imagine a celebrity mentions our app in a post. We don't just get more traffic, we get a tsunami of traffic all at once. If we're not careful, that sudden wave can overload every single part of our system at the same time, causing a total meltdown. The way you survive that tsunami is by building a shock absorber. In system design, this is called a queue. Instead of trying to process every single request the second it arrives, we can take certain jobs, like processing a newly uploaded video or sending a confirmation email, and just put them in a nice, orderly line to be handled when things are a little less crazy. And this is so clever because what the queue really does is it decouples our system. It separates the "we got your request" part from the "we're actually doing the heavy lifting" part. The main app can instantly take a user's request, drop it in the queue, and tell the user, "Got it, we're on it." Then, a separate fleet of worker services can pull tasks from that queue at a steady, manageable pace.
This makes the system incredibly resilient.
Now, underpinning all of this scaling we're doing is a really important architectural decision. And that's whether your services are stateless or stateful. A stateful service, on the right, remembers you between requests. But that's a problem. If the load balancer sends you to a different server, that new server has no idea who you are. This makes scaling a nightmare. A stateless service, on the other hand, treats every request like it's the first time it's ever seen you. It doesn't store anything. This means any server can handle your request, making it incredibly easy to just add more machines and scale out.
So it might seem like we're just collecting cool new components, right? A load balancer here, a cache there, but here's the catch. Nothing is free. Every single decision you make in system design comes with a cost. It's always a trade-off.
Just look at this table. It really lays it all out. You add that cache to get amazing speed, but the cost is that sometimes, for a few seconds, a user might see slightly old or stale data. Now, for your social media feed, who cares? That's a great trade-off. But for your bank account balance, absolutely not. And that is the true art of system design, knowing what you're gaining, what you're giving up, and making the right choice for your specific situation.
And that right there is the mantra of every great system architect. There's no such thing as a perfect system. It just doesn't exist. The right design for a video streaming service like Netflix is going to be a terrible design for a high-frequency trading platform. It's all about context.
Okay, enough theory. Let's see how the absolute giants of the tech world put these ideas into practice every single day to serve billions of us.
Take Google. They are the absolute masters of horizontal scaling with stateless services. It's how they can handle billions of searches without breaking a sweat. Now look at Amazon. Their big thing is fault isolation, making sure that if the team that recommends books has a problem, it doesn't take down the entire checkout process. And then there's Netflix. They famously make that trade-off we talked about. They choose high availability over perfect data consistency. Because let's be honest, they'd much rather you be able to watch something, even if the continue watching list is a minute out of date, than see an error page.
Okay, so now it's your turn to put on the architect hat. Seriously, you can do this with any app you use. The next time you're ordering a pizza or sending a message, just sketch out that simple diagram: client, service, database. And then start asking questions. Why is there probably a load balancer? Where would they use a cache? Are there tasks that get put in a queue?
And that's really the question I want to leave you with. System design isn't some black magic practiced only in Silicon Valley. It is the invisible logic and the set of compromises behind every digital experience you have. So next time you open your favorite app, just think for a second. What trade-offs, what careful balances between speed, correctness, and cost did they have to make to get this amazing thing into your hands?